Hello and welcome back to my CATIA tutorial series. Today we're going to be talking about plastic parts and we'll be designing this wonderful part here. We will go through the basic of solid modeling. We will touch upon draft angles. We will discuss a little bit about tooling. We will learn about the importance and design of doghouses, which is this little feature here. And we will discuss about surface sink, which is the defect that appears on the A surface of the part when you add features on the back, like this. Before we begin, we need to have some prerequisites. One is the plastic clip that we're going to use. It's I just made a simple sketch and used the revolute to rotate it around an axis. If you want to follow along, you can pause the video here and look at these dimensions. They are something I chose randomly. They are not based on some real world examples, but I think it'll be okay for this. Second is this surface. Now, you'll never be designing anything in a vacuum, so you always have some context, and in this case we're going to be using this surface, which resembles the front fender from a car. To make things even harder, we're going to be using the isolated geometry from this fender, as you will be forced to do so in some real-world applications. Again, if you want to follow along, I will include a section at the end of the video on how to draw this yourself. The specific thing about this surface is that it has a curvature in this direction, and it also has a curvature in this direction. Okay, so let's start. First thing first is to create the structure in the part. So we insert another set here. We don't want it like this. We want it here, actually. No. We insert it here. We call it constructions. We insert another set inside, and we say this is the A surface. The A surface of the part will be whatever is visible from the outside. And for the A surface, we're going to be basing this surface off this one. We're going to go ahead and switch over to the generative shape design, because we will be designing this in surfaces. And we need to extract this. No propagation. And then we're going to untrim it. There you go, beautiful surface. Now, if this resulted in a smaller surface than what we actually need, we could always extrapolate it like this. But it's fine in this case. So you can have it like 500 millimeters longer. Good. We want this our part to be slightly higher, to sit on top of the fender. So we will offset this by, let's say, 5 millimeters in this direction. Like this. Good. Now we're going to extract this surface. We're going to extract it all the way here. Unfortunately, we cannot untrim this because it has multiple faces. You can only untrim stuff that has only one face, but we can always extrapolate like this. And let's say 20 millimeters, propagation mode tangency, and it'll do something like that. Now we can go ahead and hide this this upper surface, because we want it to have like a slight curvature here, that it goes like a chamfer on this. It'll go up and then to the level we wanted it. And it also needs to have a gap to this. So the surface we just extrapolated, we will offset by a set amount. Maybe 5 is too much, but we will see that later. And then we just intersect it to this one. Keep in mind, this is the original untrim, the original surface of our support. And we have something like this. Now, maybe we needed to do this a little bit larger than it is, just to make sure we have enough room to cut. So if you already did an operation and you want to insert something inside, you can toggle this button. It's called insert mode. And you go ahead to the original surface and you extrapolate it. Let's say 50 millimeters. Click OK. And now the offset will update as well. You do the same thing on this side. And like magic, this one gets updated as well. Pretty cool. Alright, so from here we want to do a sweep. We will choose with reference surface this time. This is our reference surface, and we see here 8 degrees may be good. We want to have it something like that. Okay, we can hide this, bring back the offset, and we want to create a radius between this and this. This one goes down, this one goes down. We need a pretty large radius, and it looks like that. Now we need another surface going down from here. To create this, we will do a sweep. We could use this surface, but I rather use the draft direction. If you already know the draft direction, we will assume Y here. This will be like 82, but it's not actually 82, it's actually maybe 8. Yeah, something like that. This might be actually too long. We want to make it longer, but maybe not that long. Right, now we need to trim this one and this one, so they're the same surface. Now the reason why I don't create a radius here is because when we have plastic parts, the radius from the outside is not necessarily tied to the radius on the inside, and we might end up in a situation where we want to have like a larger radius on the inside and a smaller one on the outside. That is because plastic parts don't necessarily have to have constant thickness all the way, like you would in a sheet metal design. Good. Now we create this one. Tangent. We extract this edge here. Sorry, click this. Y direction. Make sure it exceeds here because it's something we're cutting with. And here, actually, I don't like this because it already has an edge here. I will cut it like that. And afterwards I will do this. Yeah, that is one edge there. Actually, this will need to be probably offsetted to account for the thickness and maybe some clearance. And here we will do the same. Trim. Sorry. Not the split, the trim. Perfect. Now we have our A surface. Okay, now we can start putting some thickness in. If we want, it's not necessarily required at this stage, but I generally like to visualize what I'm doing. So let's just say 3.5 millimeters thickness. Sounds about right. Right, and this is what I was saying. We need to have a radius on the inside, which is, let's say, 3 mil. And another one on the top side. Which is maybe also 3 mil. Now let's start working on the doghouses. So we need to add some support for these clips that will clip into this body here. Okay, we go into the construction tree, we create another geoset, we call it Doghouse. For this we will take this plane here, sketch on this plane. Okay, we will have a line like this. I will fast forward now for a bit because you don't really want to see me designing a boring sketch. The idea is to just minimize the surface around the clip. Right, for the Z surface I always like to do this. Make a big circle and then fill it, just to create my surface. For the main body of the doghouse we take, we can have the left direction, no problem, because this is in pure Z. And we draw it like that, and we need to make it a lot larger, I think. 150 seems about right. Maybe 5mm on the other side as well. Alright, we take this like that. The fill we will offset as well. You'll see why we do this later. We'll create a rib here. The idea of this rib is that I want it pressing on the clip to keep it locked into place. Now, like I always said, I want to be able to visualize what I'm doing here. So we will create this and call it Doghouse. And we will switch back to the mechanical design. And we will give this some thickness. 3.5, that's good. We need to put some thickness in here as well. We will make this, no, sorry. Sorry, this is wrong. We need to create a different body, like this. And we need to give this thickness as well, just like that. Now, what I want to do is to trap this little pin here in between this surface and this one. So to do that, to compensate for this, I will add a little rib here. Actually, I'll offset this a little more, just to create more space for the rib. Now go into the Doghouse geoset and create this rib. Now I don't want the rib to be touching this. I just want it to be like very, very close to that. This is fine with 4mm like that. Go into this geoset and I will give it a... I'll do a bed. Or is it a bed? Yeah, it's a bed. And give it a thickness. So it's, yeah, 3mm total should be fine. Just like that. Totally fine. Now go back to the doghouse. And we need to do a boolean operation to cut this. And the operation is union trim. But since this body here exceeds this edge, it'll be kind of hard to do. So therefore, this needs to be like this. There we go, much better. Now we can do our union trim. Union trim, select this. What faces do I need to remove? This one. Perfect. Good. Now, go back to this. Maybe change back to generative shape design. What we need to do now is create a keyhole so you can slot this in. So you can slot the clip in. This one will be something like this. Don't worry, we will make it look a bit better in a moment. So this is, I don't remember what we used. Maybe it was 12, or maybe it was a lot smaller. No, it's a lot smaller. It's this diameter here. This needs to fit here. 4 millimeters. Okay, that's the radius. So 10 should be fine. Low symmetry line. This will be actually maybe 3.5 or 4, something like that. This one would be, I don't know, 5. No, that's too low, 6. Low symmetry. Let's go with 8. And this one is 60. Make sure this is longer. Okay, now we go into the doghouse again. Or rather, we can go to this fill. Or this trim actually. And we do this little trick again, where we go into insert mode to change something that we already did and cut it with this. Let's see how it looks like. It doesn't work. And we see that we have an issue here. Okay, good. Sorry, I forgot to do this. I needed to cut this. Now it should work. So do it like that. Actually, we can go to this trim. We click insert mode. We remove this. Oh, that's beautiful. And it looks something like this. This is 7 actually. Control U doesn't work. I have all my shortcuts messed up. Right, so it looks like this at the moment. We go back to the doghouse and then we start adjusting it. Go to mechanical design, part design. Right, now we need to add some radii to this design. Don't worry about it looking really ugly, because we're gonna cut this part away. What I'd like to do first is to cut this short a little bit, somewhere like this. Go back to the doghouse part design and do a split with this plane. Make sure you select the right direction, and there you go. Now we can do the draft angle. Not like that, but like this. So this will be like probably a different draft because it's the rib. 2 millimeters. Yeah, that's fine. 2 degrees, sorry. And the rest should have maybe a different draft. This should be draft as well. Let's see, 3 degrees. Alright, good. Now we need to add some radii to this design. First, let's start with this. Yeah, that looks pretty good. This one's probably gonna be a bit larger radius. I keep misclicking. Yeah, and that's the doghouse. The way it works is you slide this clip in, and this will keep it leveled. So this one you will be demolding it in this direction. It'll be a secondary direction from the main body. The way it works is you have a slider that goes into this this little pocket here. So once the mold opens in this direction, this slider will slide in and out like this. Almost, well, not almost, but perpendicular to the main direction. Yeah, there you go. Now, all that's left to do is to duplicate this all the way around the part. To do that, we go to Generative Shape Design, we create another geoset here. So we call this position. Maybe I can call this design. And move everything from here to here. And go into the position one. What is the important point for us? It's this one actually. This is where it will meet with the other part. So this is actually the reference point we're gonna use. We're going to insert here a axis system. We do not want it to be current, and we do not want it to be on the axis node. We want it here actually. That's good. Click OK, and now we need to generate this stuff here. To do that, I think I'm going to extract this surface. I'm going to offset it slightly. 3 mm should be fine. This is because I want it to be the little interfaces where these doghouses where these clips will fit into the body will be flat, and this is not a flat surface, so I need like a small bump and to create a flat surface there. Right, I will extract this edge here with tangency, and we'll create a parallel curve like that. Don't know where it's gonna end up yet, but I'll do this. 65 maybe, I don't know. I'm going to, as a support, I will use the ZX plane. That's good. Not tangent to curve, I want it normal. 90 degrees. Do we still keep the support? Yes, we do. Good. And here I will insert an axis system. The Z needs to be don't know why I don't have the option to select the plane here, but we can go with coordinates. The Z needs to be actually the Y plane. This means it's going to be parallel to Y. And the other axis, it's the Y, this direction, needs to be like this. Now the way to do it, I just copy this. And if I move the point like that, maybe like that, it'll just move the whole construction here. That's just that's an easy way to duplicate stuff. Very easy. This one I'm going to reverse direction and put it here. Maybe like that. I don't know. Kind of want it on a straight surface. Good. Now to duplicate this all around, I just need to copy this doghouse, Ctrl C, and do a paste special as a result with link. And here in this one, switch back to part design, I'll do an axis to axis transform. This one here. You click OK on the error message, then you select the first axis, then the second axis. And we see that it's not in the right direction. This needs to be reversed. Good, now we can just copy this. How many times? 1, 2, 3. Now we just replace the axis system to this, to the new one, and there you go. Right, but are we happy with this? No, we are not actually. Because I don't know if you've seen any parts and how they look like actually, but the doghouse here, when it meets the surface, has a thinner section here. Why do we have that? That is due to surface sink. So when you have plastic parts, you have what is called an A surface, which is this one, a visible surface, and a B surface, which is the back of the A surface. Now when you have features on this, like ribs, doghouses and other stuff, stuff with thickness, usually, it creates a buildup of plastic here, and when the plastic cools off as it exits the mold, it will start to shrink. And because you have like a larger buildup of plastic here, it'll shrink more in this area, and it'll cause a defect on the A surface here, like a little hole. So that's something we want to avoid. And one of the good design ways to avoid this is to have a good ratio between the thickness of the part and the thickness of the wall on the inside, and that is supposed to be no more than 0.75 times the thickness of this the main part thickness. Right, so you could do this manually for each of these doghouses, or you could do it automatically, which is how I'd like to do it. Just a second, this kept annoying me. Yeah, now it's more evenly spaced. So first thing first, we need to stop this thickness at a certain point. We want to stop this somewhere here. So in order to do that, we create another body, and we join all these features together in a single body. We use the add command for everything, Alright, switch back to generative shape design. Find my A surface. This is the offset, and from this offset we actually need to offset it back. We have 3.5mm thickness plus maybe 5mm. Okay. Then we go back to this. We go to part design. We cut this with this surface. Perfect. Now, to generate the thin part of the doghouse, we need to basically start the process over again. So we create another body here. Look for this surface here where we created the doghouse. Design here. This sweep here. This is the one. Just need to copy this one, but here instead of 5 we put -20. Okay, we could just go -5 here to make it a little bit smaller. This is what we want, and here in the body we increase this thickness here. We create the thickness for this sweep, and it should be maximum 3.5 times 0.75, which is 2.65, whereas we don't like this value, so let's just put it 2.5. And now we can split it as well. Split it with this plane. Same plane we used last time. Okay. And we do the exact same thing. We copy it. As a result, we blink. And here we do a axis to axis transformation. Okay, now you can add this. You can go here, add this to this. That's perfect. So this is doghouses, and the last add is thinning. Maybe, whatever, doesn't really matter. And now you go to this one. No, sorry. This one is the main body. So this, you put here a surface, and then under the, no, it's not a surface, it's, call it main. And here you do a union trim this time. And you select these ones, and then faces to remove. I don't know if it's necessary to remove all of them. Let's see. Yeah, it's necessary to select at least one face from each body. Okay. Now we see one big issue. These are the other way around. They should have been oriented downwards. Go back to construction and reverse the Y for this, and actually for all of them. We need to reverse the Y. And for some reason it doesn't work anymore. Faces to remove. There. Good. Okay, and let's talk trimming. So we go over to the construction geoset, switch back to generative shape design, and create a trim set. Here we'll use a lot of surfaces that we already used for the A surface. So, for example, we have this one here, and we need to offset it slightly. This one, you create an offset. It's not gonna be 5 millimeters as we used before. It's gonna be something like maybe 2.5 or something like that. Do we want to trim this entire flange, this entire body with this? Probably not, because it's gonna end up in a weird shape. We don't want to do that. So what we actually want is to trim this surface here, the A surface. Actually, this sweep over here, we are going to trim this one before we join it to the rest, like that. Other side, this one, and then we update, and we get a totally different thing here. Now this one is going to be a bit tricky. For this one, we will be using, I think, this surface here, the one we offset it. No, not this one. We have an extract of this, and good, it's one single surface. What we can do is actually do surface on trim to get the base surface, like that. It's a little smaller than what I expected, but we can work with that. Make sure it's curvature, extremity is tangent, and if we put point continuity, we can make this larger in all directions like that, which is totally fine. Yeah. Good. Now we make sure we make it long enough. Let's say, I don't know, 12. 12 should be fine. Then we need to also trim it here, and we also need to trim it here. For this, we'll create a sketch on this plane, and we will have one like this, so separate sketches. Where do I want to trim it? Well, maybe something like this. Okay, another sketch here. I want to have an angle to this one. Maybe 45, maybe 50. Right, is this good enough? Who knows, maybe, but I'm thinking I need to have a parallel line like this. So I can control it better. Good. Okay, now we go back to the main shape. We switch back to part design and we trim it. trim ones like this, ones like that, and ones like, where is it? This one. This is the offset, and ones like that. Okay, go ahead and hide the set and hide everything. It's already looking pretty smooth. Still some work to do, but it's not bad. Right, these doghouses, I think we can move them a little bit like that. To have a little clearance here. You've noticed that we have not used this, so let's fix that. I will create a body in which we will close this surface. Now we have an actual surface, and we copy this and we do the same. Paste special as resultant link. By now you must be familiar with the axis to axis transform. And we have our clips as well. Right, now we can start adding the radiuses to our part. We have here maybe 5. I don't know. How does it look? These we could live with a little more radius here, and these ones, I guess. Oops. We need to have a radius here. Okay, here I'm not happy about how this looks. I think we may have selected the wrong trim. Now let's check what we did here. It's probably, sorry, not here, it's in the trim area. We have not used the correct value here. Something like this. Right, how to do some little final touches to the part. These ends need to have something here to close them up and stiffen them a little bit as well. So I will create another geoset here. I'll just call it, I don't know how to call it, maybe ribs. Yeah, that seems fine. Maybe take one of these lines and create a plane. Look at it from the other side, look at it from the other side, okay. This, something like that. Like this. Let's see, 50. For the purpose of this video, I don't feel like putting any more effort into creating this. Otherwise, it'll take like forever to refine everything. So I will just create a sketch like this, unconstrained, which is like totally wrong to do, but this video is going to take really long time. if I start to look into every single detail. I do the same here. 5, 4. Where's the plane? Where's my plane? Forgot the plane. There it is. Sketch. Same here. Sorry, this 50. Do something. Switch part design. We will create a new body, and we will create a pad. In this direction is 2.5 millimeters, and in the other side here we will create another pad, and it's 2.5 millimeters in this direction. Now we go here to the main body, we select union trim, faces to remove the outside, and there you go. Okay, now the last thing I want to do is to add 2 screw holes in this part, which I will place them one here and another one here. So to do that we need to change the trim first. Remember when we use these surfaces as trim? Yeah, well, we're gonna have to change that a little bit. So it's mainly this one that we're going to be updating. Let's see. What can we use here? We're gonna use this curve. Maybe this one, the first one we extracted, and we're going to project it. Where the hell is the project button? Project. We're going to project this curve here, and we are going to project this curve. And we are going to... Sorry, no. We don't need to project this. We're going to intersect this with this. And we end up with... this curve. Let's say 450. So we have one here, and we're gonna have one probably here. 50 mil. That seems about right. 90 degrees. That is totally fine. Do the same here. We select the curve, we select the support, and point 90 degrees, done. Then we create a sweep. Actually, we need to create a cylinder, so the easiest way to do that is to just create a sweep. Select this one and center on radius. And the radius is 20. Seems about right. Same here. Now, what we need to do is take this offset and create a radius between these two. Done. Now if you update this, of course some edges you might need to reselect, some are going to be reselected right away, and you get this one. You do the same here, select the trim, the latest trim, insert mode, you create another fillet, boom, instant radius. Okay, now probably need to create a hole as well. We're gonna go with radius 5. Same here. I don't know, man. Maybe 5 is a bit low. 6. It is a clearance hole. And now we have a choice. We can either do it in the body or do it in the surface. I think I'm gonna do it in the body now. Okay, hide everything again, and it appears that we forgot something here. We still have sharp edges here, which I really don't like. So what we need to do is to start adding edge fillets to them. You can see here that it feels really hard to click on the edges. To solve this issue, we can go here. Depth effect, near limit fixed. You can fix it to 50 or something like this. Sorry, 100. And then you can zoom in like that. And you will be able to select the edges like that. So this is a really useful tool. It allows you to clip through some geometry. Two might be too much. This is like maybe 0.5 or something. Yeah. There you go. And deselect this, and that's fine. I'm gonna save this, and that's it. That's how I would design a plastic part like this one. You might end up needing different workflows, different features on this side, maybe add some ribs, but that's really straightforward stuff to do, and I'm pretty sure you can manage this on your own. If you're not interested in how I designed the base input surface, then I guess that's it. Thank you for watching, and see you again next time. But however, I did promise I will tell you how to do this, and we're gonna start doing this now. So first we're gonna try this in a new part. You create a point. There should be a center point. Just a basic circle around this point. Yeah, I don't like this. Should be in this direction. Good. This is a circle, half circle like this. Make it 500mm diameter, just so it resembles something like a wheel. Doesn't have to be accurate, but you need to do this first to get the sense of the scale. Then you need to add a sketch like this, make a spline with a relatively soft curvature. We don't really care about the exact size. Then we create on the perpendicular plane another spline, and this one has slightly more curvature to it. Maybe less on this side, but more on the bottom side. Something like that. I don't know if this is actually more curvature or not. It could be. Right, exit. And then we sweep one with the other. With reference surface, you choose one. Sorry, not reference surface. Yeah, no, it should be reference surface, but it should be okay. We need to sweep one line with the other. This one, it should be with tangent surface with reference surface, I guess. No, it needs to be here with reference surface, but it needs to be this type. Choose one profile, choose the other one. That's one. You can see this is like way too low. There it is, much better. Now we need to define this this arc here. This we can extrude Y like that. We're going to be extrapolating this down with the tangency here, all the way up to, let's say, here. Then we're going to do an extrude in X direction, like that. We will fillet these together. Let's see, 20. That is perfectly fine. We are going to then intersect this to the curve. Where's the intersection? Always lose the intersection. Intersect. Good. I guess we calculated this for 500 millimeters. Then we are going to sweep this line again with reference surface, but we are going to take this subtype here because we don't need a second curve, we just need a surface like this. 8 degrees, it's actually 82 degrees, something like that. So this is like the downward angle, and then we need to offset this surface by, let's say, 30 mil. You can already start creating the fillets like this. And like this. Cool. Now what's left to do is to trim this large surface. You have one trim line here, 45 degrees. We can actually go (360) like that. What I was saying is that we don't really care about this lower point here. We can actually leave it like this. So we have one trim like that, and the second one we will offset this in this direction by 30 seems too low, something like this. 68, at which point this one becomes not so good. Then we do another trim. Yeah, that's it. You can use this as a base surface. And then you can use this as a base surface for your design. So again, thank you for watching, and hope to see you again. Until next time.